A black aircraft is about to leave the runway on its first official test flight. But there is a problem nobody can solve with an ordinary wrench. The aircraft needs titanium. And some of the best titanium available is sitting inside the country this aircraft was being built to spy on. The United States had already learned the hard way what happened when a spy plane was caught. On May 1, 1960, Soviet air defenses shot down CYA pilot Francis Gary Powers's U-2. The U-2 had changed reconnaissance by flying extremely high. Now, Washington needed something almost impossible, an aircraft that could fly higher, faster, and farther than the defenses trying to stop it. That requirement eventually produced the A-12 OXCART for the CIA, and later the SR-71 Blackbird for the U.S. Air Force. The target was extraordinary: cruise around Mach 3, operate above 80,000 feet, and gather intelligence while outrunning threats rather than simply hiding from them. But speed created a problem. At Mach 3, the airplane itself gets hot, very hot. The skin could reach temperatures approaching 800 degrees Fahrenheit. Aluminum, the material used extensively in conventional aircraft, was not the answer. The engineers needed titanium. And in the early 1960s, obtaining large quantities of high-quality titanium was a serious problem. One of the world's strongest sources was the Soviet Union. So American intelligence faced an almost absurd situation. To build a plane designed to watch the Soviet Union, they needed metal that the Soviet Union produced. Titanium wasn't chosen because it sounded futuristic. It solved a very specific engineering problem. It was strong for its weight, resistant to heat and corrosion, and much better suited to the temperatures this aircraft would experience. But titanium came with its own nightmare. It was difficult to machine, difficult to form, difficult to fasten, and difficult to weld. Lockheed's engineers weren't simply building an airplane out of titanium. They were practically learning how to manufacture titanium aircraft from scratch. The CIA itself describes titanium fabrication as one of the major technological challenges of the OXCART program. And every mistake became expensive. A conventional aircraft could tolerate ordinary manufacturing problems. The Blackbird couldn't. At Mach 3, a tiny weakness could become a catastrophic failure. Now came the intelligence problem. The Soviet Union had developed a major titanium industry. The United States needed titanium for a secret aircraft. But simply placing an American order for Soviet strategic material would have been a spectacular way to reveal what Washington was building. So the CIA used cover companies to acquire titanium through international channels. The operation was designed to make the purchases look ordinary. According to the Smithsonian, the CIA established shell companies abroad to buy titanium from the very country the aircraft was intended to spy on. Think about the irony. The Soviets were producing the raw material. American intelligence was secretly buying it. Lockheed was turning it into an aircraft. And that aircraft would eventually fly reconnaissance missions against Soviet bloc targets. It was almost as if the Soviet Union had unknowingly helped manufacture the machine meant to penetrate its defenses. But getting the metal was only half the problem. Working with it was another battle. Normal tools didn't behave normally. Drills wore out. Cutting tools could break. Fasteners and fabrication techniques had to be developed specifically for the aircraft. Lockheed even had to develop its own titanium screws and rivets. Special tooling and forming techniques were required because titanium behaved very differently from conventional aircraft metals. And then came the problem of making thousands of individual parts fit together. The engineers were dealing with an airplane that would change temperature dramatically in flight. At ground level, it was one machine. At Mach 3, it was a heated structure expanding under enormous aerodynamic stress. That meant the aircraft couldn't simply be assembled like an ordinary jet. Everything had to account for heat. The airframe wasn't the only thing struggling. The engines had to work in conditions that looked more like a physics experiment than conventional aviation. The Pratt & Whitney J58 engines were built to power the aircraft at extreme speeds, and even the engine program fell behind schedule. CIA records from the OXCART development period show that Lockheed's titanium work and Pratt & Whitney's J58 development were both causing major delays. This wasn't a normal aircraft program. The engineers weren't taking proven components and assembling them into something new. They were creating new solutions because the existing ones simply didn't work at the required speed and altitude. The aircraft was forcing American industry to reinvent parts of aerospace manufacturing. And the clock was running, because the Soviet air defense problem wasn't going away. Here's the part that makes the titanium story so strange. The biggest danger wasn't necessarily getting caught buying Soviet titanium. It was getting the titanium into the aircraft and making the whole system work. The material itself became part of the secret. The supply chain had to stay hidden. The manufacturing process had to stay hidden. And the airplane had to survive a flight environment that conventional aircraft were never designed for. The CIA's A-12 eventually reached its design specification of approximately Mach 3.2 at 90,000 feet. And then something remarkable happened. The aircraft didn't need to be invisible in the traditional sense. It could run away. If an enemy fighter or missile was coming after it, the aircraft's answer was essentially, "Go faster." That philosophy became one of the defining characteristics of the Blackbird. The airplane wasn't protected by armor. It wasn't protected by fighter escorts. Its protection was altitude, speed, and intelligence, and the titanium structure helped make that possible. The CIA's A-12 OXCART became operational in 1965. The Air Force then operated its own development of the aircraft, the SR-71 Blackbird. The Blackbird entered service in 1966 and went on to fly reconnaissance missions for decades, and the result was extraordinary. On July 28, 1976, an SR-71 established an absolute speed record of approximately 2,193 miles per hour. That's about Mach 3.3. The same day, another SR-71 established the sustained altitude record for a manned aircraft at 85,069 feet. And those records still define the aircraft's reputation. Only 32 SR-71s were built. Yet the aircraft became one of the most recognizable symbols of Cold War aerospace engineering. But perhaps the most fascinating part isn't the speed. It's the contradiction at the heart of the aircraft. America built a machine designed to watch its greatest Cold War enemy. And to build that machine, American intelligence secretly sourced some of the material through the very country it was watching. The enemy didn't know exactly what its metal was becoming. But every time that Blackbird climbed into the sky, Soviet radar operators were trying to figure out how to stop it. The SR-71 wasn't just a fast airplane. It was a collection of problems that engineers somehow turned into a working machine. Heat titanium, engines, stealth, altitude, and an intelligence operation strange enough to involve buying strategic material from an adversary. Sometimes the most incredible machines aren't created because the technology already exists. They're created because someone decides the impossible has to work. Stories like this are why we tell the hidden history behind the machines that change the world. Subscribe for the next story.